All right, this is Algebra lesson 1.4, and that is the distributive property. I know you guys have had this stuff last year with me lots in pre-algebra, but we're going to go over this. The distributive property is where you distribute a number by either multiplying or dividing it to a set of numbers. For example, and this is the kind of thing you've been used to, is 2 times x plus 1. Everybody should look at that and instantly think distributive property, right? Because I'm going to distribute this. I can't add x and 1 together because I don't know what x is, right? I have no idea. So I'm going to simply, this is 2 times whatever's in here. Here's how you do it. What do I say? I say rainbow, rainbow, right? Rainbow, rainbow. I'm going to multiply the 2 by whatever's inside the parentheses. 2 times x is 2x. Another rainbow. 2 times 1 is 2. What goes here? A plus sign, because this guy right here comes down. So this thing here, simplified, is 2x plus 2. Make sense? Okay. What if I have something bigger? You guys try this. Try, it's ugly. Just because it's ugly, nothing changes. Work on it. See if you can do it. All right, it's very simple. We're simply going to do rainbow, rainbow, right? We're going to go x times 3 is 3x. X times a negative 4y. What is x times negative 4y? Negative 4xy. It's that simple. And we're done. Right? Distributive property. Now, here's the thing. That is the distributive property. We also, and we'll talk about this right now, even though this is not part of your homework, we can use the distributive property, and we'll use it a lot, using division, okay? Like, for example, if I have 2x plus 4, and I'm going to divide that by 2, we actually can use the distributive property here. Because remember, division is simply multiplication. So watch this. I want you to watch this so you can see what you're allowed to do. This is in parentheses. You agree that there's parentheses here, invisible ones? Right? There's invisible parentheses up here. And the whole thing is being divided by 2. How can I change divided by 2 into a multiplication problem? Times by 1/2. Instead of divide by 2, I multiply by 1/2. So what's the difference between this question here and 1/2 times 2x plus 4? What's the difference? They're identical, right? So I'm going to go rainbow. What's 1/2 times 2x? Half of 2, just x. And then what is 1/2 times 4? Makes sense? I don't expect you to rewrite that like this. You can use the distributive property with just straight up division. I'm going to go like this, and I think I've shown you this before. I'm going to go like this. What is 2x divided by 2? What is 2x divided by 4? What is 4 divided by 2? There it is. Does that make sense? Does that make sense? That's not for a little while, but you're in algebra, and this is coming. And this is going to be a little bit like, it's coming. Okay, something else. You have to be able to do what is called combine like terms. What are like terms? If I was to give you this string and I asked you to simplify this, what does that mean, to simplify this? What am I talking about? I'm talking about, I want you to combine like terms, right? Make it as simple as you possibly can. Can I combine the 2x and the y? No. Like terms mean that they have the exact same variable with the exact same exponent. Okay? So I cannot combine these because I have an x here and a y here. Not like terms. Right? But I can combine this 2x with this negative 4x because they're both just x's. Does that make sense? Now, I could not combine them if this was 2x squared. I cannot combine 2x squared and 4x. I can't combine them. They're not the same. They're not like. In order for them to be like, they have to be the exact same variable with the exact same power. Make sense? But it doesn't. It's just like that. So let's combine these terms. This is what I do. I'm an algebra teacher, and I still do this to keep my head wrapped around things, that every term has its own symbol in front. It's either positive or negative, right? You got to keep them separate. I'm going to go by and I'm going to grab these terms and make sure that they each have their own symbol. Oh, wait a second. Where's this guy's symbol? It's an invisible plus sign, right? Combine them now. I have plus 2x and minus 4x. What is 2x minus 4x? They're gone. They're gone. Now what? Do I have anything to combine with that y? Plus y. Anything to combine with that 3? Plus 3. And we're done. Does that make sense? Combining like terms. I know you've done this, but we've got to make sure this has got to be so grounded. Okay? What about this then? Here's a question for you. Let's see if you can do it. You do this one on your own. All right, here we go. Let's see. The first thing we need to do is you have to recognize something. And what do you recognize right off the bat? Distributive property, right? You got to deal with the distributive property right off the bat. Rainbow, rainbow. What is 2 times x? What is 2 times negative 4? Negative 8. I'm done with that now, and I bring this down, plus 5x. What am I allowed to do now? If you left this, I would mark it wrong. What am I allowed to do now? Combine like terms. Can I combine this 2 and that 8? No. What about the 8 and the 5? No. Why not? They don't have like terms, right? But can I combine the 2x and the 5x? Absolutely. Combining them, 2x. Now listen, this is the part. Why do you think that I want to grab terms? Everybody grabs a term because how easy would it be for you to go 2x minus 5x? Do you see what I'm talking about? Don't you see how that would be easy to do? You might make that mistake because the negative is right after the 2x, and so you might go, okay, 2x minus, right. So then make sure you go and everybody, I still do this, people. I make sure everybody grabs the term in front of them. So now I go, oh, it's 2x plus 5x. What is 2x plus 5x? 7x. They're gone, and that leaves me with minus 8. I'm done. How many of you got that? 7x minus 8? Okay. Are you following? Does that make sense? Okay. Let's try another one. Let's try another one of these good babies. Let's do... I'll give you a difficult one. There you go. Try that for me. All right, here we go. Lots of things here in this that, you know, are kind of a mess. This thing's long and ugly. But what should you recognize right off the bat? Oh, you should look at this and see the distributive property, right? So rainbow, rainbow. So we're going to take care of that right now. We're going to bring everything else down. 4x squared plus 3x. Now we're going to do the distributive property, which is 2 times x plus 2x. 2 times negative 5 minus 10. Okay, now that I've done that, what am I supposed to do now? See if you can combine like terms. Can I? Yes. Okay. Can I combine this 4x squared and this 3x? Why not? They're right. One of them is an exponent, one is not. You can't just combine them. They have to be the same letter with the same power. You can't combine them otherwise. So can I combine the 3x and the 2x? Okay, so 3x plus 2x is 5x. So 4x squared plus 5x minus 10. Is there anything else I can combine? How many of you got that? Excellent. Okay, good deal. Let me see if there is... let me give you the hardest one on the... Okay, here, I'll give you one more that's kind of weird. Okay, try that. It's weird only because there's a bunch of negatives. You just have to deal with them, right? You're just dealing with the negatives. Okay, nothing changes just because things look difficult. The rules don't change. All you do is you look at this and you see distributive property, right? Okay, rainbow, rainbow, bang, bang. Okay, so what is negative 3 times a negative 4? 12, right? 12. What is negative 3 times a negative m? A negative times a negative is a positive, so 3 times m is... Now, is there any problem with you leaving it like this? Not at all. I'll tell you, normally you're going to want to put, well, we'll get to this later, but there is generally like a pre-decided order for things to be laid out, but for now, that's fine. There's nothing wrong with this at all. How many of you got 12 plus 3m? Did anybody flip it and make it 3m plus 12? Good. Okay. This is no problem. Now, one thing, here's the deal. I'm going to give you something practical for the distributive property. I don't know that you know this, but you can use the distributive property to help you do basic stuff. If I have 8, and I'm going to multiply that by 8 times, we'll just say 12. I know that a lot of you know that by heart, right? But really, it's no different than 8 times 12, which is no different than 8 times 10 plus 2. And what is 8 times 10? 80 plus 8. What is 8 times 2? 16. What's 80 plus 16? 96. There's your answer. My whole point here is that if I give you one that's kind of ugly, like 8 times, and a lot of people don't know 8 times 15 right off the bat. You know what I'm saying? Like you don't really, that's not one you have memorized. Use the distributive property. What's 8 times 10? See, that's not a 1, that's a 10, right? What's 8 times 10? 80. What's 8 times 5? 40. What's 80 plus 40? 120. There you have it. Do you see what I'm talking about? You can use the distributive property to help you do mental math. Do it in your head. See what I'm talking about? You can do it in your head by using the distributive property. You know, what about something like this? Let's do an ugly one. Let's do 24 times, we'll do 2.5. So all of a sudden, there's no work here. I don't want you to do any work. I want this done in your head. Here's the deal. You go, okay, what is 24 times 2? 48. Keep 48 in your back of your head. What's 24 times a half, or half of 24? 12. What's 48 plus 12? 60. You just did a nasty one. Thank you very much. Okay, I think that's going to be plenty. Perfect. You just did a pretty ugly one, 24 times 2.5, in your head by using the distributive property. I bet you didn't know you could do that before. You see what I'm talking about? What if it was an ugly one like 2 1/3, and all of a sudden you're like, oh, that'll never work. Wait, 24 times 2 is 48. What's 24 times 1/3, or divided by 3? 8. What's 48 plus 8? 56. In your head, you just did it, where you would have never, you would have looked at that and you'd be like, oh, great. And you'd have gone through the 24 over 1 times, right, 7 over 3, and then you don't need to do that. Distributive property is awesome. For real. It's awesome. All right. Let me look and see what I got for you for your homework. I have 11 through 40. Let me see if that's going to cut it for me. Okay. We'll do that. We'll do page 27 through 28, 11 through 40 even.